Cambridge igcse Chemistry, Paper 2, Multiple Choice Extended, October-November 2025, Paper 23. Let's solve it. Question number 1 states, what happens to the volume of a fixed mass of gas when pressure and temperature are separately increased? So, we have a fixed volume of gas. First, let's increase the temperature and then we're gonna increase the pressure. We have fixed mass of gas. The volume we are gonna change. These are the particles of gas. Now, if I increase the pressure, how do I increase the pressure? I cannot change the temperature. I only have to increase the pressure. I can change the volume. How do I change the volume? If I move the piston upwards, my pressure is going to decrease. Why? Because the spaces between particles is gonna increase, and if the spaces between particles increase, that means, and the walls are gonna increase, that means there are gonna be less collisions per unit volume or per unit area. Like with the walls, per unit area, the collisions are gonna decrease if I increase the volume. So to increase the pressure, and pressure is the collisions of the particles with the walls of the container. So to increase the pressure, I need to decrease my volume. If I decrease my volume, what's gonna happen? The particles are gonna move closer to each other. And when the particles are gonna move closer to each other, and my walls are gonna decrease. Now I only have this much walls. What's gonna happen? There are gonna be more collisions per unit area. So pressure increased, volume of the gas has to be decreased. Okay? Understood? Temperature increased. So for the same, now this is now again my volume. Now what do? I heat it from below, and let's see, I'm providing it heat. Now what's going to happen? The gas is gonna expand. When we heat things, the gas expands. Why does it expand? Because the intermolecular forces between the particles is broken. And if the forces are gonna be broken, what's gonna happen? Particles are gonna move far away from each other, and the kinetic energy of the particle increases. So they're gonna vibrate faster and faster and faster and move away from each other. So now, since the gas is gonna expand, particles move further apart and the volume increases, because now particles need more space because they have to move further apart. So what happened to my volume when I increase the temperature? My volume increases because my piston basically moved upwards. So this is what's going to happen, and I explained you the logic and reason behind it. Just telling answers is easy, but you have to understand that what's happening. Always remember, whenever you increase the temperature, the kinetic energy increases. Only temperature can change the kinetic energy of the particles. Okay. Sorry. Which gas diffuses most quickly at room temperature and pressure? Okay, so which gas is going to diffuse most quickly? Do you know that the rate of diffusion of gases depends on the MR of gases? So if you have more MR, you have greater diffusion or less diffusion? You have greater mass, so less diffusion. And if you have less MR, then your gas is lighter. And if the gas is lighter, LIGH, that means it can diffuse more. So we have to find the MR of all the gases. For methane, carbon is 12, hydrogen is 1 times 4, because there are 4 of them. That's going to give me 12, 13, 14, 15, 16. C2H6, 2 carbons plus 6 hydrogens. 2 carbons means 12 plus 12 plus 6 hydrogens, 30. 30 for this. Carbon monoxide. Carbon is 12. Oxygen is 16. 28. SO2. Sulfur is 32 and oxygen is 16. Sulfur is 32 plus 16 plus 16, 64. 64. Which gas diffuses most quickly? The one that's going to be the lightest, 16, that has the least amount of MR. And if the question reversed and they asked you that which gas diffuses least quickly, then it would have been SO2 because it's the heaviest. The more heavy you are, it's more difficult for you to move. And I think that makes sense. Which statement defines nucleon number? Nucleon number basically means this is your atom. Okay, this is your atom. This is the nucleus inside the atom. Nucleon number means everything that inside the nucleus. What do we have? We have protons and we have neutrons. So nucleon number is the number of your protons plus the number of your neutrons because they're inside the nucleus. It is the total number of protons in the nucleus. No, it is the number of everything that's inside the nucleus, including protons and neutrons, okay? It is the total number of electrons. Electrons are not included because electrons are outside the nucleus. We don't include things that are outside the nucleus, okay? What is the total number of neutrons? What is the total number of neutrons in the nucleus of an atom? No, not only neutrons. It is the total number of protons plus neutrons. It is the total number of protons and neutrons in the nucleus of an atom. Yes. What's everything inside the atom has to be included. Okay, the symbol of 4 atoms are listed. Which atoms have more neutrons than protons? Okay, so we're going to calculate the protons and neutrons of every atom. First, you need to realize this number that's written below is the number of protons. This is called the proton number, or you can also call it the atomic number. Okay, so let's just make a table kind of thing, protons and neutrons for every like this. So for protons, I'm going to write the proton number here is 6 because I can see it. 6. Over here it's 6 again. Over here it's 7. Over here it's 14. This one's the proton number. Done. Now I need to figure out the number of neutrons. How do you figure out the number of neutrons? This minus this. 6 minus 12 gives me 6. 14 minus 6 gives me 7. 8. I have to do it because you cannot rely on anything. 14 minus 6. My maths is pretty bad, so 8. Okay. 14 minus 7, 7. 29 minus 14, 15. Done? Now what do? You look that which atoms have more neutrons. This one has equal protons and neutrons, so we're not dealing with this. This one has more neutrons. It is 8 neutrons. This one has equal number, and this one has more neutrons. That's 15. So it's 2 and 4 that have more neutrons compared to protons. Done? Which statement describes all positive ions? How does an atom form a positive ion? Let's take the example of sodium. So this is sodium, and sodium has 2 shells. In fact, it is 3 shells. Now, how is it going to form a positive ion? Electrons, 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 electrons. When an atom is going to lose one electron, it's going to form a positive ion. So for a sodium atom, the electronic configuration is 281. But for a sodium ion, what's going to happen? This electron, the last one, is going to be lost. And once this electron is lost, the electronic configuration becomes 28, and it becomes a Na positive 1 ion because now it has one more proton. So to form positive ions, you need to lose electrons so that you have more protons compared to electrons. Positive ions have more electrons. No, they have more protons. They have more protons than neutrons, not more protons than neutrons, more protons than electrons. They have more electrons. No, they have more protons than electrons. Okay. Since you're losing electron to form a positive ion, the protons are eventually going to be more. A sample of copper has a relative atomic mass of this. What are the relative abundances of the isotopes in the sample of copper? Okay, 63.5. Just by looking, you can tell it's option A, but I'm going, no. Sorry. It's option C, 75 and 25. But I'm going to do entire chemistry with you. How do you do it? No problem. You have two isotopes. One is your 63 isotope and the other one is your copper 65 isotope, okay? Let's consider that the abundance of the 63 isotope is going to be X, okay? So the abundance of 65 isotope is going to be 100 minus X, right? Because the percentage abundance is out of 100. So if this one is X, this one is going to be 100 minus X. So what do? We say 63 multiplied by X, and then we say plus 65 multiplied by 100 minus X. Done? Now what do? Divided by the sum of abundances, which is going to be 100, equals to 63.5, which is the relative atomic mass, okay? We multiply the mass with the abundance of the first isotope, mass of the other isotope with the abundance of the other mass of the other isotope multiplied with the abundance of the other isotope divided by 100. Sure. Now what do? We just find the value of X from here. We make equations like 63X plus 6500 minus 65X equals to 635120. This minus this is going to be minus 2x equals to 6350 minus 6500. We solve it. I've just doing simple maths. Multiply this with this with this with this, bring this here. Okay, so now 6350 minus 6500. 6350 minus 6500, negative 150, minus 2x equals to negative 150, x equals to negative 150 upon negative 2, to 1 times to 75 times, x equals to 75%. Because we considered X to be the percentage of 63. So the percentage of the 63 isotope is going to be 75, and if that's 75, what's going to be the percentage of the 65 one? It's going to be 100 minus 75, which comes out to be 25%. Got it? Which diagram shows the outer shell electron arrangement for a molecule of methanol? Okay. Methanol means that we have one carbon, so carbon is going to have how many electrons in the last shell? It's going to have a total of 4, but after forming bonds, it's going to have 8. So look over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since this diagram shows that carbon has 10 electrons cross, every atom should have how many? 8. This shows 4. If an atom, by making bonds, does not stabilize, then what's the purpose of making bonds? You make bonds so that you can stabilize yourself. And if you're unable to stabilize yourself, the bonds are useless. You need 8 electrons to stabilize. Now look over here. Over here, oxygen is not stable. Oxygen has 1, 2, 3, 4. No, oxygen needs to have 8 electrons after making bonds. We need stability. Cross. Look over here. Carbon has 1, 2, 3, 4, 5, 6, 7, 8. Good, stable. Now let's count for oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Stable. Hydrogens. Hydrogen only has 1 shell. Dekho. Carbon has 2 shells. The second shell needs to have 8. Oxygen has 2 shells. So the second shell needs to have 8. But hydrogen has only the first shell. And the capacity of the first shell is to have 2 electrons. So 1 2 here, 1 2 here, 1 2 here, 1 2 no 1 2 here, 1 2 here, 1 2 here, good, and 1 2 here. So all hydrogens are stabilized as well. Okay, over here, if a question like this comes in your exam, you guys have to make sure that you make everything stable. Hydrogen, put the 2 electrons. For carbon, put the 8. For oxygen, put the 8. Rescuers are drilling through fallen rock. Rescuers are drilling through fallen rock in order to rescue some people trapped in a cave. Okay, there's a tragedy that has occurred, so now they're like helping the people. The drill needs lubricating from time to time. Okay, the drill needs lubricating from time to time so that it can work better, because lubrication means you add some slippery material like graphite. Graphite is a good lubricant. 4 statements are made about the materials used for the drill tip. Drill tip needs to be hard and strong. Okay, and the lubricant to explain the reasons for their use. Diamond is used for drill tip as it does not conduct electricity. We don't care about the electricity. For the drill tip, we only care it's hard and strong. Diamond is used for the drill tip as it's very hard. Yes, graphite is used as lubricant as it conducts electricity. No, electricity conduction is not the purpose of drilling. The purpose is that it should be hard, and lubricant we use so that it's slippery. It's soft and slippery, yeah. We need it to slip so that it lubricates. 2 and 4. Done? Next. Which compound has an empirical formula that is the same as its molecular formula? Okay, butane. What's the molecular formula of butane? It is C4H10. Okay, butanene. It does not matter if it's butanene or butene. It's going to have the same molecular formula. C4H8. Butanoic acid. It's going to be C4H8O2. Butane monoate. It's going to be C4H9OH. So now see it for yourself. Now make the empirical formula for each one of them. C4H10. 2 times, 5 times. So this becomes C2H5. 2 times, 4 times. So this becomes, and then 2 1 times and 2 2 times. So CH2. 2 1 times, 2 4 times, 2 2 times. This becomes C2H4O. And then this is C4H10O. This cannot be further, cut. So this is going to be our answer, because this cannot be further cut on a single table. Like this is 1, this is 10, this is 4. We cannot cut them on any single table. That's why this is going to be the empirical formula as well as the molecular formula for butanol. Which row identifies the charge on chromium ion and sulfate ion? Chromium ion and sulfate ion in this. It's very simple. I'm going to tell you a nice cool trick if it helps. How do you find charges in ionic compounds? It's easy. You take this, bring it up here. This becomes a 2 negative. You take this, bring it up here. It becomes a 3 positive. Otherwise, you can think of it like if chromium has a charge of 3 positive, 2 chromiums are going to have a charge of 6 positive, right? And if sulfate has a charge of 2 negative, 3 sulfates are going to have a charge of 6 negative. So a 6 negative is going to balance out a 6 positive. But that's a difficult way. You just bring this thing up here and this thing up here. So that's going to help you. Chromium is a 3 positive here, and a sulfate is a 2 negative here. Which statement describes a saturated solution? Saturated solution means maximum amount of solute is dissolved. Now there's a difference between a saturated solution and a saturated hydrocarbon. Saturated hydrocarbon means they're carbon-carbon single bonds only. That is what a saturated hydrocarbon means. But a saturated solution means that maximum amount of solute is dissolved. Got it? It is a solution that contains the maximum concentration of solute. Yes. It is a solution that contains maximum amount of solvent. Solvent doesn't matter. Solvent is like if you have this solution and you have water in it and then you have this salt in it. Adding more salt is the solute. Water is the solvent. Adding more salt is going to make it saturated, or adding more water? Obviously adding more salt. So adding the solute makes something concentrated, not the solvent. Remember this. It's a hydrocarbon. No. A saturated solution and a saturated hydrocarbon are two different things that you should realize. Calcium carbonate decomposes when heated strongly. How many gaseous molecules are produced when 10 gram of calcium carbonate is completely decomposed? So we have 10 grams of calcium carbonate. What is going to be the first step? Whenever we have mass of anything that relates maths in your igcse chemistry is going to be related to moles. So if you're given with mass, you have to calculate the number of moles. So over here, what do? We say moles equals to mass, which is 10 gram upon the MR. MR of this thing is going to be calcium is 40 I guess. Carbon is 12, oxygen is 16 plus 16 upon 100. Moles come out to be this 0.1 moles. Now I have the moles of calcium carbonate. I need to figure out what is my eyes on the prize. How many gaseous molecules are produced? Are there going to be molecules produced of calcium carbonate? No, because calcium oxide is a ionic compound. Calcium oxide is an ionic compound, and ionic compounds don't produce molecules. What do they produce? They produce formula units. Carbon dioxide. This is going to form molecules. So we're concerned with how many molecules of carbon dioxide are going to be produced. So look at how many moles of carbon dioxide are going to be there. We got 0.1 moles of calcium carbonate. Now the ratio of moles of calcium carbonate and carbon dioxide is 1:1. So if you have 0.1 moles of this fella, we are going to produce 0.1 moles of carbon dioxide. Got it? So now we know that 1 mole of anything contains 6.02 into 10 exponent 23 particles. So if you have 0.1 of moles of carbon dioxide, we're going to have X amount of particles. Now we figure out the value of X. X equals to 0.1 into 6.02 into 10 exponent 23. And when we're going to multiply this, we are going to get the answer 6.02 into 10 exponent 22, which is option number C. Got it? You just had to figure out the moles of calcium carbonate, from that the moles of carbon dioxide, from that you just had to use the ratio. Done. Which product is initially obtained at each electrode? Which product is initially obtained at each electron during the electrolysis of concentrated aqueous sodium chloride? Okay, you need to first realize that you've concentrated sodium chloride. Okay, concentrated NaCl. That means how many ions you're going to have? You're going to have hydrogen ions for water, OH negative ions for water. For sodium chloride, you're going to have Na positive ions of sodium and chloride ions. When you have concentrated solution, always remember you never form the hydroxide, like the oxygen from the hydroxide. You always form the halogen. Chlorine gas is going to be formed at the anode. Okay? Chlorine and chlorine at the anode. At the cathode, what are we going to form? At the cathode, we are going to form hydrogen. Why? Because sodium is above hydrogen in the reactivity series. And what do we form? We always form the things that are below in the reactivity series. So over here, we're going to form hydrogen. Molten lead bromide is electrolyzed using inert electrodes. Which statement describes the movement of electrons? Always remember. Negative and positive. Negative is your cathode. Positive is your anode. At anode, what happens? Oxidation or reduction? Oxidation. And oxidation is your loss of electrons. So at the anode, things lose electrons. And at the cathode, what happens? Your reduction happens. And what is reduction? Reduction is your gain of electrons. So what's going to happen? This entire thing is going to move. The electrons that are lost at the anode is going to move like this to the cathode. So electrons are going to move from the anode to the cathode. So they're going to move like this, okay? So electrons move from, this is X, this is Y. So electrons are going to move from X to Y through the electrolyte. Now what is electrolyte? This solution is the electrolyte. And this thing is the external circuit. So electrons are basically not, I told you, electrons are not moving like this. A second. Electrons are not moving like this. They're not moving like this. Not from the solution. They are moving from the external circuit like this. Not in the solution and then. So not from the electrolyte, but from the external circuit. From X to Y in the external wire. In a fuel cell, a fuel is oxidized to produce electricity. Oxidized means oxygen is added to it. So what is the thing that gets oxygen? Simple is that in a hydrogen oxygen fuel cell, we have hydrogen, we burn it, that means we add oxygen to it, and then we form 2 moles of H2O, and there's a 2 here. So simple hydrogen being added to oxygen to form water. So the fuel is the hydrogen because hydrogen is being burned. An oxidizing agent is obviously oxygen because it's oxidizing it. Water is the product, not the oxidizing agent. Okay? So option B. Which statement about the reaction is correct? A reaction that is vigorous at room temperature has high activation energy. No, if it's vigorous at room temperature, then it has a low activation energy. It can happen at room temperature. Something that has high activation energy does not happen at room temperature because it needs a lot of temperature to basically cross that energy barrier. Okay, so cross. If delta H for a reaction is positive, bond making in the formation of the products is endothermic. Okay, if delta H for a reaction is positive, that means more energy is utilized in breaking the bonds than energy that's released when bonds are formed. So bond making in the formation of the products is endothermic. Bond making is endothermic. Never. Bond making, no matter if the reaction is exothermic or endothermic or whatnot, bond making is always exothermic. Even in endothermic reactions, bond making is exothermic. The problem in endothermic reactions is that more energy is realized in bond breaking, which is endothermic. So that makes the reaction endothermic. Not the bond making can be endothermic. It has to be exothermic. In both exo, bond making is exo, bond breaking is endo. Cross. In an exothermic reaction, the energy required to break bonds is less than the energy released to make bonds. Exothermic reaction, the energy required to break bonds is less than the energy released when bonds are formed. That is correct. More energy is released during bond, always remember, exo means more energy released during bond making than absorbed during bond breaking. Okay, we don't even need to read the last one, but it says reactions with a positive enthalpy change always transfer thermal energy to the surroundings. They absorb thermal energy from the surroundings. A positive enthalpy change means absorbing thermal energy from the surroundings. Okay, ethene reacts with hydrogen to form ethane. The bond energies are shown in the table. What is the enthalpy change for the reaction? First, you have to break the bonds. You have to break this bond, this bond, this bond, this bond, this bond, and this bond. So how many bonds do we have to break? 1 carbon-carbon triple bond, 4 carbon-hydrogen bonds, so 4 CH bonds, and 1 hydrogen-hydrogen bond. So these are the bonds we need to break. Plug in the values. 1 carbon-carbon triple bond, which is 614, plus 4 CH bonds, which is 410, plus 1 HH bond, which is 436. So that's the sum of all this is going to be the energy that you're going to absorb to break the bonds, to break this bond, this bond, this bond, this bond, this bond, this bond. Okay, so now energy is going to be released when bonds are formed. This bond is formed, this is formed. Okay, 1 carbon-carbon bond. So 1 carbon-carbon bond is formed, and 1, 2, 3, 4, 5, 6 CH bonds are formed. 6 CH bonds. So 1 times 350 plus 6 CH bonds, 410. 350 plus 6 times 410, whatever this is going to come out to be, this is going to be the energy that's going to be released. This is going to be the energy that's going to be absorbed. You're going to subtract this value and this value. And when you subtract these two values, you are going to get negative 120. That means this value is going to be bigger because this has a negative sign, and the answer is coming out to have a negative sign. Got it? This and this is going to be subtracted. That's simple. Zinc reacts with dilute hydrochloric acid. Let's write the reaction. Zinc reacts with HCl to form ZnCl2 plus hydrogen gas. You have a metal, you have an acid, you're going to form a salt and hydrogen. Okay? Just remember that whenever you have metal plus acid, you form salt plus hydrogen gas. Increasing the concentration of dilute hydrochloric acid, increasing the concentration increases the collision rate but has no effect on the activation area. That is 100% correct. Because when you increase the concentration, look, I'm going to show you. This is my acid number 1, okay? It has 1, 2, 3, 4 particles. Now, if I increase the concentration of it, that means I'm increasing the number of particles, okay? Now I have these many particles. Now, God's honest truth, tell me, are there going to be more collisions in this reaction 1 container or the reaction 2 one? Obviously more collisions over here because there are more particles. So increasing concentration increases the amount of collisions you're not going to have, but doesn't affect the activation energy. Activation energy, remember, can only be changed by one thing. Only a catalyst can change the activation energy. Only a catalyst can change the activation energy. Done? Done. Ethanol is manufactured by the addition of steam to ethene. Steam to ethene. Ethanol. The reaction conditions are 300 degrees Celsius and 60 atm pressure. The forward reaction is exothermic. The forward is exo, that means backward is going to be endo. Which row describes the effect on the equilibrium yield? Statement 1 says adding a catalyst. Catalyst only affects the rate and activation energy, so it's going to have no effect on the equilibrium yield. That is correct. Decreasing the temperature. Decreasing the temperature is going to make the forward reaction happen, that is exo, because when you decrease the temperature, the equilibrium tries to increase back the temperature, and for that you have to do the exo part, decreasing the pressure. When you decrease the pressure, equilibrium move towards the side that has more moles. There are 2 moles on the reactant side and 1 mole on the product side. So when you're decreasing the pressure, equilibrium is going to move toward the side that has more moles. That's going to move backward. So the yield of this ethanol is not going to increase, it's going to decrease. So this is incorrect. Only 1 and 2 are correct. Which identifies the conditions used to make sulfur trioxide in the contact process? You have to learn the conditions that you have 200 kilopascals temperature in vanadium oxide catalyst. This iron is used in the Haber's process, not in the contact process. Which statement describes a base? A base is a proton acceptor and an acid is a proton donor. It reacts with ammonium chloride to produce ammonia gas. It reacts with ammonium chloride to produce ammonia gas. Ammonium salts react with alkalis to produce ammonia gas. We're going to consider it like, we're going to see it, but let's read the other statements as well. But that's correct that, bases plus ammonium salts give off ammonia gas. You know why? Because, no, that's an A-levels concept. I would not like you guys to ruin your understanding, but this makes sense. Let's read other as well. It reacts with calcium carbonate. No, calcium carbonate itself is a base because it neutralizes an acid. It reacts with copper to produce hydrogen gas. That is what acids do, not bases. It turns blue litmus red. No, bases turn red litmus blue, not blue red. Okay, so option A. It basically releases ammonia plus water plus a salt. This is a reaction you should know, that bases or alkalis react with your ammonium salts to form ammonia plus water plus salt. The equation shows the reaction between copper and concentrated nitric acid. Copper is a metal, nitric acid is an acid. What do you form? Acid plus metal. This is what you're forming. Which element is reduced in the reaction? Okay. So we write the oxidation states. Copper is a 0 here. Here it's a 2 positive. So copper is oxidized. If copper is oxidized, something has to be reduced. Check for nitrogen here. Hydrogen is a positive 1, oxygen is a negative 2, negative 2, 3 oxygen. So negative 2 times 3, this gives me a negative 6. To balance out a negative 6, you need a positive 6. Positive 1 is being given by hydrogen, so nitrogen is going to be a positive 5. And so from a positive 5 nitrogen here, let's look nitrogen here, it's a positive 4. Check it for yourself. Oxygen is a negative 2. 2 oxygen means there's going to be a negative 2 times 2. That's a negative 4. To balance out a negative 4, you need a positive 4. So, from positive 5 to positive 4, oxidation or reduction? Decrease in oxidation number or increase? There's a decrease. And whenever you have a decrease in oxidation number, that is reduction. So, what's being reduced is your nitrogen. Understood? Just see it for yourself and you're going to realize it yourself. But for that, your redox things should be very good, that you instantly realize the oxidation numbers. Okay. The product table shows the position of 4 different elements. Which was correct? Element non-metal. A is a non-metal. No, it's a metal, right? This is group 1, this is group 2. Why would group 1 be non-metals? So incorrect. Metal, yeah, B is a metal. Number of electrons in the outer shell. It's in group 2. Group 2 means 2 electrons in the last shell. The group number tells the electrons in the last shell. So cross. C is a metal? No. C is... Sorry. I'm so sorry. I didn't realize one thing, that this is B. I thought this was B. B is in group 1, 2, 3, 4, 5. So firstly, it's a non-metal because it's in group 5. So this is again a cross. C is a metal. It's a metal and it's in group 2. So it's going to have 2 electrons in the outer shell. Got it? Dilute acid R and dilute acid S have the same concentration. Okay. The same volume of each dilute acid is reacted separately with the same mass of magnesium ribbon. Okay. Both reactions are carried out at room temperature and pressure. The volume of hydrogen produced is measured. The graph of the results is shown. This line is the volume of hydrogen. This one is a steeper gradient. This one is a less steep gradient. That means this reaction happens faster, this reaction happens slower, but the concentration is the same. So the amount of hydrogen being produced over here is the same for both reactions. Acid S reacts faster than acid R. No, actually it's slower, not faster. This has a less steep gradient, this is a more steep gradient. So R is reacting faster. Incorrect. The final volume of hydrogen produced in each reaction is different. It's the same. Look, final volume is same. Acid R is a stronger acid than S. Yes, it's a stronger acid because look, it ionizes faster and produces hydrogen faster. S is slower. So R is going to be stronger acid. Got it? This is correct. S is a stronger acid. No. Look, for S the rate is slower, so it's going to be a less strong acid. Okay, which metal oxide reacts with aqueous sodium hydroxide to form salt in water? Calcium oxide, copper oxide, sodium oxide, aluminum oxide. We need the oxide to react with sodium hydroxide. Calcium oxide is a sodium hydroxide, you need to realize, is a metallic oxide. If it's a metallic oxide, it's going to be basic. Done? Calcium oxide with a basic oxide, what's going to react? With a basic oxide and acidic oxide is going to react. So calcium oxide is a basic oxide, so not going to react. We need an acidic oxide. Copper oxide basic, sodium oxide basic, aluminum oxide. This thing is amphoteric. If this is amphoteric oxide, that means it can react with both metals as well as non-metals, both with acidic as well as basic. So sodium hydroxide is going to react with aluminum oxide because aluminum oxide is not basic, it's amphoteric. Got it? And amphoteric oxides, the good thing is they react with both acids and bases. Which identifies a transition element? Transition elements have characteristic properties, high melting points and high densities. Okay. Which statement about group 1 and group 7 elements is correct? Group 7 elements are monatomic. Look, fluorine, chlorine, bromine, iodine, astatine, they're all diatomic. Why diatomic? Because look, F2, Cl2, Br2, I2, AS2. That means that there are two atoms that are covalently bonded to form a molecule. Lithium is more reactive in water than cesium. No, down the group, look. Lithium, sodium, potassium, cesium, francium. Down the group, the reactivity increases. So, cesium is going to be more reactive than lithium. And why? Because cesium has a bigger size. If it has a bigger size, it can lose electrons more readily. So, incorrect. The melting point of group 1 metals increases down the group. No, it decreases down the group. Why? Because as you go down, the metallic bond weakens. Why does the metallic bond weaken? Because the cation size increases. So the attraction between the cation and the delocalized electron is decreasing. Over here, lithium is smaller in size, so there is more attraction between the cation and the delocalized electron. So lithium is going to have a higher melting point compared to francium. The melting point of group 1 metal increases or decreases. Potassium bromide reacts with chlorine to produce an orange solution. That is correct, that if you have potassium bromide and you make it react with chlorine, what's going to happen? Chlorine is more reactive than bromine, so it's going to displace bromine. We are going to form KCl plus Br2. And this Br2 that we're forming is going to be what in color? It's going to be orange in color. So this is correct. Some information about four metals. PQRS is listed. Metal P does not react with HCl. Okay. T is definitely going to be either copper or silver or gold, because magnesium does. Metal Q is more reactive than magnesium. Calcium is more reactive. Potassium is more reactive. Aluminum is not. Metal R reacts rapidly with cold water to produce hydrogen. Iron does not. Calcium reacts with cold water. Metal S reacts with dilute hydrochloric acid to produce hydrogen. It's going to be zinc. Got it? Cars are fitted with catalytic converters. Which equation represents the reaction that takes place in a catalytic converter? What do catalytic converters do? They convert your nitrogen oxides to nitrogen gas, and they convert your carbon monoxide to carbon dioxide gas. Okay, so over here we're producing carbon monoxide. That is toxic, so we don't want carbon monoxide. Over here we're producing carbon dioxide. Okay, good. This is what we need, and the other product we need is nitrogen. Yeah, good. 2 products formed, option B. So you just have to see where you're forming the right thing. Over here we again have nitrogen oxide. These are going to cause photochemical smoke. We don't need it. Oh my god, this is the worst thing you can do. This is going to cause photochemical smoke, and carbon monoxide already so dangerous is going to kill you in seconds. Okay. 3 statements about greenhouse gases and global warming are listed. Greenhouse gases and global warming. A greenhouse gas molecule can absorb and emit thermal energy. What happens when you have a greenhouse gas like methane? Why is it called a greenhouse gas? It's called a greenhouse gas because this is your earth and this is the sun. You are my sunshine, my only sunshine. You make me happy when I cried. You remember that poem? Okay. Thermal energy is going to come from here, and these gases are the culprits that are going to absorb it. And when they're going to absorb it at night, Earth emits some energy back to the space. But since these gases are going to absorb it, it's going to be difficult for Earth to radiate the energy. So when the Earth is going to radiate back the thermal energy into the space, it's going to become a source of thermal energy. So this statement is also correct. The last statement, thermal energy emitted by a greenhouse gas is sent out in all directions, is also correct, because obviously you are releasing energy out of a gas molecule. It's not like only it's going to be released here or here. It's released in all directions. 1, 2, and 3. Option number A. Which type of reaction takes place when methane reacts with chlorine in the presence of UV light? UV light, do you remember? Substitution reaction, methane and chlorine. Chlorine is going to replace the hydrogens in methane. Okay, iron is extracted from iron 3 oxide in the blast furnace. 3 steps in the process are listed. Carbon is completely oxidized. Okay, so you need to realize one thing over here that's important. Okay, what is the correct order? We have to write the order. So first, carbon is oxidized, okay, iron is reduced, and carbon dioxide is reduced to carbon monoxide. So the 3 equations are first this, then this, then this. So the first one is carbon is completely oxidized. That's going to be the first step. Then carbon dioxide is reduced to carbon monoxide. You can see it's the reduction reaction. Why? Because carbon dioxide is losing an oxygen to form carbon monoxide. Carbon dioxide has 2 oxygens, but carbon monoxide has 1 oxygen. So this is a reduction reaction. So first this is gonna happen, then this is gonna happen, 1 3, and then iron oxide is reduced to form iron in the last step. So 1 3 then 2, 1 3 then 2, which is option B. 3 different reactions occurring during the extraction of aluminum from purified bauxite are listed. Which reactions occur at the anode? You know, at the anode we cannot have positive ions. At the anode we have negative ions. Firstly, oxide ions are gonna form oxygen and 4 electrons. Good. And then what's going to happen? The oxygen gas that's produced is going to react with the anode, because anode is going to be made up of graphite, which is carbon. So oxygen reacting with the carbon, the oxygen that's formed reacting with the anode, going to form carbon dioxide. So it's 2 and 3. Which statement about aqueous ethanoic acid is correct? It reacts with magnesium to form oxygen gas. No. Acid, this is an acid, this one's a metal. Acid plus metal doesn't give oxygen, it gives hydrogen. So over here we form hydrogen gas. It reacts with sodium carbonate to produce carbon dioxide. That is correct, because whenever you have an acid, make it react with the carbonate, you form carbon dioxide, salt and water. It turns red litmus paper blue. No. Acids turn blue litmus paper red. It turns methyl orange yellow. No. Alkalis turn methyl orange yellow. Acids turn methyl orange red. The diagram represents these 4 monomers. The monomers each react in a 1:1 ratio with dicarboxylic acid as shown. How many of the 4 monomers shown can react with a dicarboxylic acid to form a polymer? Firstly, I think some things are very clear over here, that this is a diol, and we know diol and dicarboxylic react to form a monomer, right? So this is going to react. Then there's an amine group. We know amines react with carboxylic to form amide linkage, and alcohols are going to react to form ester. Good. Polymer formed by this. Then we can see there's an amine over here. Amine is going to react, but the problem is we have a carboxylic over here. So carboxylic cannot react with the carboxylic. Got it? So carboxylic and carboxylic cannot react with each other. So there's a cross here. Then again, we have an amine and amine. Both amines are going to react to form polymers. So you might think this amine might react. Yeah, amine might react, but we need a polymer. Polymer means a length of monomers. Like there should be a chain of monomers. Because of this carboxylic, we're not going to have a chain. Propene undergoes addition reaction with bromine, hydrogen and steam. Which structures represent the product? Firstly, this is not a possible product, because if you have a double bond here, then 1 bromine should add here and 1 bromine here. It is not possible. Please write it down. I know examiners test this a lot. It is not possible to have 2 bromines like this. Why is it not possible? Because there's a carbon here, a carbon here. There can't be a double bond between these 2 carbons. Either it has to be between these 2 carbons, then it would have been bromine here and here, or it would have been between these 2 carbons and it would have been here and here. Not possible. Again, this is not possible because there's just 1 bromine. If there's a double bond, HBr, is there any HBr? No, not HBr. So if there's a double bond, then bromine should add on both carbons, not only on 1 carbon, again across. Okay, this is possible because if there's a double bond here, then 1 hydrogen here, 1 hydrogen here. If there's a double bond here, 1 hydrogen here, 1 hydrogen here is going to be added. This is also possible because 1 OH and H from the steam that you are adding. So it's H, OH, OH here, H here. It is possible. So 3 and 4 are only possible. Got it? Why is this not possible? If they would have said HBr, then this would have been possible because hydrogen here and bromine here, but they've only said bromine, hydrogen and steam. So if you add bromine in the double bond, both get the bromine, not only one. Okay. The structures of 4 compounds are shown. Which compounds are members of the same homologous series? So first one is the alkane series, the second one is the alkene series, the third one is the alcohol series, and the fourth one is also alkane series. So alkane and alkane belong to same homologous series, so 1 and 4. Alkene because of the double bond, alcohol because of the OH functional group. Which statement about ethanoic acid is correct? Ethanol is reduced by bacteria, no, oxidized by bacteria. Ethanol oxidizes to form ethanoic acid. Ethanoic acid reacts with magnesium to form a... This formula is incorrect. Why is this incorrect? Because look, this is a... What kind of ion is this? What kind of ion is this? Ethanoate, methanoate, propanoate, ethanoate. Ethanoate ion has a charge of -1. Magnesium has a charge of +2. So we need 2 ethanoate ions to balance out the magnesium. Over here, there's just 1 ethanoate ion. Incorrect. Incorrect. Ethanoic acid and methanol can react in the presence of an acid catalyst to form ethyl methanoate? No. To form methyl ethanoate. Methyl is the part of the alcohol. Ethanoate is the part of the acid. Ethanol reacts with acidified aqueous potassium manganate to produce ethanoic acid. That is correct. Ethanol oxidizing by an oxidizing agent. This is the oxidizing agent to form ethanoic acid. Substance X contains 1 cation. Substance X contains 1 cation. 2 tests are completed. A flame test. Addition of aqueous sodium hydroxide dropwise. Which row shows a possible combination for the 2 tests? Yellow flame, white PPT. Yellow flame means it has sodium, and sodium does not give white PPT with NaOH. Blue green flame. Well, you should know blue green flame is for copper. If this is for copper, then light blue precipitate insoluble in excess of NaOH. That is correct. Copper gives light blue precipitate, so correct. Light green flame, that's for barium, and green PPT, barium gives white PPT. Red flame, that is for lithium, and red brown PPT, that is for iron 3+, so not possible. A colorless mixture is separated by paper chromatography. The steps below describe the method. These steps are not in correct order. The steps are not in correct order. What is the correct order for these steps? Correct order. Okay, so first I would say either it's 3 or 5. So first let's read 3. Spray the chromatography paper with a locating agent. 5 says draw a pencil line at the bottom. Firstly, I'm going to draw a pencil line, obviously. So first draw a pencil line. Then it's 4. Place a spot on the mixture. Okay. Then either it's 3 or 2. 3 says spray the chromatography paper with locating agent, and 2 says place the chromatography paper in the solvent. Over here, you need to realize one thing, that first we place it in the solvent, and at last we spray it. We don't spray it like immediately. So we're going to put it in the solvent. After that, once the chromatography is done, then we spray the locating agent to see where are the spots. Then remove the chromatography paper from the solvent. Okay, we're going to remove it. Then draw a pencil line to mark the position of the solvent front. And then at last, we're going to spray it with the locating agent. Got it? And with that, we're done with this paper.